Hello students, how are you? I hope you are all excited in this new normal classroom. So I'm Sir Joel Mahilom from Santa Ana National High School, Division of Davao City. So in this module, we'll be discussing lessons in week 1, particularly competency number 1. So in this video, we'll be discussing lesson in module 1, which is factoring of polynomials. So these are the objectives. So after watching this video, you are expected to factors completely different types of polynomial, such as polynomials with common monomial factor, difference of two squares, sum and difference of two cubes, perfect square trinomials, and general trinomials. Then what is factoring? So let us remember lessons in way back in elementary. So these numbers had been introduced to us like prime numbers. So we all know that prime numbers, it is a natural numbers greater than 1 whose factor is 1 and itself. For example, 2, 3, 5, 7, 11, and so on. So as you can see, the factor of 2 is only 1 and itself. So 1 times 2 is 2. So there's no other numbers that we can multiply that the result is this number except for 1 and itself. So other numbers, we call it as composite numbers. So these are numbers that can be expressed as the factor or product of two smaller natural numbers. For example, 6 out 4. So this is 2 times 2. 6, 2 times 3. 8, 2 times 2 times 2. 9, 3 times 3, and so on. So for polynomials, we also have prime polynomial. And with this prime polynomial is what we so-called non-factorable. So of course, there are polynomials which are factorable. So what if we will multiply any of these numbers or polynomials? So for example, if I multiply 2 and 3, the result is 6. So how do we call these numbers? Other terms. So we call it as factors. The resulting answer, we call it as a product. So if we have an expression 3 times x, quantity x plus 5, so the answer is 3x plus 15. So by using the distributive property, 3 times x is 3x, then 3 times 5 is 15. So 3 times 3 and x plus 5 are the factors, and 3x plus 15 is the product. So suppose we have this example, x plus 2 times x minus 1. So doing again by FOIL method, so x times x, that is x squared. X times negative 1, so that is negative x. 2 times x is positive 2x. 2 times negative 1 is negative 2. By simplification, so we can combine like terms, negative x plus positive 2x. So we just, this is negative 1. So negative 1 plus 2, subtract. So 2 minus 1 is 1. The sign of the greater absolute value is positive. That is why it is positive x. We just copy negative 2. And again, we call it, these two quantities are factors. And this answer is a product. Then factoring, by the way, if you answered the question previously, factoring is a process of finding the factors given the product. So we just reverse the process. So by multiplication, we have this number, we are looking for the product. So in factoring, the product is given, we will be looking for the factors. So it is a reverse process of multiplication. So let us also recall prime factorization or finding the GCF or the greatest common factor. So what are the prime factors of the following? So for example, 15. So what are those two numbers that you are going to multiply? The answer is 15. So in elementary, we use this branching. So this is 3 and this is 5. So 3 times 5 is equal to 15. Notice 3 and 5 are all prime numbers. So therefore, the prime factors of 15 is 3 times 5. Another number is 120. So again, by branching, so any all even numbers is divisible by 2, but we can shorten the process by taking 12 and 10, because if we multiply 12 and 10, the answer is 120. So factor out 12 such that one of its factor are prime. So it's gonna be 3 times 4. So notice that 4 is still a composite number. So the prime factors of 4 is 2 and 2. So these are prime numbers already. So how about the 10? So the prime factor of 10 is 2 times 5. So therefore, the prime factors of 120 is 2. So how many 2's? 1, 2, 3. So 2 times 2 times 2, then times 3 times 5. Or we can express this one into an exponential notation. So there are three 2's that we multiplied. So it can be expressed as 2 raised to the power of 3. Then copy 3 times 5. So first lesson we're going to discuss is the common monomial factoring. So these are the steps in factoring a polynomial by common monomial factoring. First, we're going to determine the common monomial factor, or we call it as, we abbreviated it as CMF of the terms in the given expressions. Okay, so the constant, of course, this is the greatest common factor. For the variable, to have the common monomial factor, this is the common variable with the smallest exponent. So after which, we're going to divide each term of the given expression by the common monomial factor to obtain the remaining factor. So for example, 8x squared minus 12. So first, we're going to find the GCF, or the greatest common factor of the constant, which is 8 and 12. So the prime factor of 8 is 2 times 2 times 2. The prime factor of 12 is 2 times 2 times 3. So what we're going to do here, we will try to take a look with those factors which are common to the two numbers. So in this case, 2, merong 2 dito, we also have 2 here. So these factors are common. So this common factor, we write it, it's 1. This common factor, we bring it down, this is 2. So these are the two numbers which are common to these numbers. Common factors, by the way, to these numbers. So therefore, the greatest common factor of 8 and 12 is the product of 2 times 2, which is 4. So therefore, the common monomial factor of the constant, or of this term, 8x squared and 12 is 4 only. Why we don't have x? Because in the second term, there's no x, only in the first term. Okay? So to obtain the remaining factor, what you're going to do, each given term will be divided by the common monomial factor. So in this case, we divide it by 4 and also divide it by 4 to obtain the remaining factor. So therefore, 4x squared divided by 4 is 2x squared. Then negative 12 divided by 4 is negative 3. So therefore, this is the factored form of 8x squared minus 12. So to check whether these factors are correct, so all you have to do is just multiply. So to multiply this one, we use the distributive property of multiplication. 4 times 2x squared is 8x squared. Then 4 times negative 3 is negative 12. So that's how you check. You just multiply to have the product. Okay? So given the product, these are the factors. So let's have example number 2. So factor completely 25x cubed y plus 10x y squared. So again, the common monomial factor of 25 and 10, this is one way of getting the common monomial factor. So we will factor the first term, 25x cubed y. So this is 25. So prime factor of 25 is 5 times 5. So there are 3 x's. So 3x times x times x, because the exponent is 3, and 1y. In the other term, the 10x y squared, this is 2 times 5, then y, x, then 2y's. So take note of the common. So we have common 5 here. We also have x, and we also have y. So those common factors, write them as 1. So therefore, the common monomial factor is 5, x, and y. So that is 5xy. So after having the common monomial factor, we will divide each term by the common monomial factor, which is 5xy. So divide 25x cubed y divided by 5xy. So to obtain the remaining factor. So 25 divided by 5 is 5. X cubed divided by x. So we will subtract the exponent. So that is x squared. Notice that y divided by y is 1. So that is why we cancel out 1. So for the succeeding term, 10 divided by 5 is 2. Then cancel out x because the quotient is equal to 1. Then y squared divided by y is y to the power of 1. So this is the factored form of this given expression. Another example. Factor completely 6m squared n cubed p to the power of 4 plus 3m to the power of 4 p minus 9m cubed p cubed. So one way of checking the common monomial factor is like this one. So I'm teaching you another way. So the common monomial factor, of course, of 6, 3, and 9 is 3. So as what I have said in the previous slide, since each term, this term, and this term, and this term have m as the variable, so that m will be included in our common monomial factor. But how do we know which of the m that we're going to write in the common monomial factor? We will take a look with the exponents of this m. So in this first term, m exponent is 2. The second m is 4. The third m in the third term is cube. So the smallest exponent will be taken as part of the common monomial factor. So since m squared is the smallest, kaya nga this is m squared here. So notice in the first term has n, the second have no, and the third have no n. So therefore we cannot take n as the common because from the word common it must be present in all the terms. So in this case, we will take P instead. Why? Because P are all present on all these three terms. So which of them is the lowest exponent? So this is P. So this is the P that we use in the common monomial factor. So we have now the common monomial factor. We will divide each term by the common monomial factor to have the remaining factor. So 6 divided by 3 is 2. Then m squared divided by m squared cancel out. So n, there's no n, so we just copy n cubed. Then p to the power of 4 divided by p, subtract the exponent, so that is p cubed. Then proceed to the succeeding term. So 3 and 3 is 1, so cancel that out. So m to the 4th divided by m squared, so subtract the exponent. 4 minus 2 is m squared. So cancel out p because their quotient is equal to 1. Then, last term, 9 divided by 3 is 3. Then, m cubed divided by m squared is 3 minus 1, so m. Then, p to the power of 3 divided by p, so 2 minus 1, that is p squared. So, this is now the factored form of this given expression. Again, if you want to check, you just multiply and it will go back to this given expression. So let's proceed to another lesson, which is factoring difference of two squares. So before we will do this, we have to recall about multiplying polynomial, particularly special product, which is sum and difference of two terms. Suppose we are multiplying both binomials. They have the same first term, they have the same second term, they only differ into the operation. This is plus, the other one is minus. Or it can be written interchangeably. This must be minus and this must be plus. So it can be either way. So in order for us to multiply binomial to a binomial, we have the so-called method which is commonly used, known as the FOIL method. So if we will multiply it by FOIL method, you will multiply it. So FOIL stands for the first term, the outer terms, the inner terms, and the last terms. So the first term, multiply a times a, so that would be a squared. Then a times negative b is negative ab. Then b times a is positive ab. Then b times negative b is negative b squared. So as you can see, these two terms are the same, but they are opposite in sign. So they are additive inverse. So if we add number, the same number in opposite sign, their sum is equal to 0. So therefore, this is cancelled out. So what is left now is a squared, and we just copy minus b squared. So this is called difference of two squares. So if we multiply product of two binomial having the same terms, they only differ into the operation, the resulting answer or the resulting product, we call it as difference of two squares. So for example, x plus 5 times x minus 5. So in order for us to have this product, now we may not do the FOIL method to have the product. All you have to do is just follow the pattern. The answer in this polynomial, if you multiply, is only two terms, which is the first term is the square of the first term of the binomial, then minus, always minus, then square of the second term. So in the order to do this, so we just square x, then always minus. Our b is 5, so we square 5. So x times x, which is x squared, is x squared. Then 5 times 5 is 25. So that is why the answer is x squared minus 25. Another given is 2x minus 3y times 2x plus 3y. So again, these two expressions are identical in terms. They only differ into the operation. So again, square the first term, which is 2x, quantity squared, then minus 3y, quantity squared. So 2x times 2x is 4x squared, then 3y times 3y is 9y squared. So this is the product. Then lastly, we have m cubed plus 4n p to the power of 2 times m cubed minus 4n p to the power of 2. So they are also same, the sum and difference of two terms. So we will square the first term. The loss of exponent, a raised to the power of m times a raised to the power of n is equal to a m plus n, which means if we multiply polynomial or expression with the same base, all you have to do is just copy the base and other exponents. So if we multiply m cubed by itself twice, so m cubed times m cubed is equal to m to the power of 6. Then minus, so square of 4 is 16, square of n, so n times n is n squared. Then p to the power of 2 times p to the power of 2 is p to the power of 4. So this is now the product of this given expression. How do we know that the given product is a perfect square? So suppose the numbers are the following. So 1, 2, 3, 4, 5, and so on. So until infinity. So if we square 1, so 1 squared, so that would mean that 1 times 1. So the answer is 1. So this is the x squared. So 2 squared is 2 to the power of 2. So 2 times 2 is 4. So take note of the exponent. Do not multiply the base and the exponent. Instead, multiply the base by itself, indicated by the exponent. So for example, 3 to the power of 2, that would mean that you are going to multiply 3 2 times. So 3 times 3 is 9. So 4 times 4 is 16. 5 times 5 and 25 is 25, and so on. So these numbers are called perfect squares. So these are, and so on, and these are the numbers which are called perfect squares. If you heard the word square root, so to obtain the square root, what are those numbers that you are going to multiply by itself twice? The result are the perfect squares. So let me cite an example. What is the number that you are going to multiply by itself twice that the result is 1? So definitely 1. What is the number that if you're going to multiply by itself twice, the result is 4, so that is 2. The result is 9, so that is 3. That would mean that the square root of 1 is 1, the square root of 4 is 2, the square root of 9 is 3, the square root of 16 is 4, the square root of 25 is 5, and so on. Okay? Now, how do we know that a given variable? Because in the polynomial, we are dealing with constant and variable together in one term. So how do we know that a given variable is also a perfect square? So ito yon. So we can know that a variable is a perfect square if and only if its exponent is divisible by 2. Why is it divisible by 2? Because to obtain the square root, we just divide the exponent by 2. If you will just cite the illustration here. Okay? So if this is x squared, this is the number squared, being squared, so x squared being squared, so loss of exponent, power of a power rule, we have to multiply the exponent. So 2 times 2, so that would be 4. So the square of x squared is x to the power of 4. Similarly, the x square of x cubed is x to the power of 6. The square of x to the power of 4 is x to the power of 8. So conversely, the square root of x to the power of 4 is x to the power of 2. That would mean, to obtain the square root of the variable, we just divide the exponent by 2. So 4 divided by 2, so that would be x to the power of 2. So therefore, this is now the square root of these numbers here. So this concept is very important as we move along to this lesson. So what are the steps in finding or in factoring difference of two squares? So first, what you are going to do is you will get the square root of the first and the second term. This will be the first binomial factor. Secondly, you just copy the factor, but you have to change the operation. For example, okay? So before you will factor the given polynomial, if the given factor is only two terms, you have to take a look if the expression or the operation given is minus. So if the operation is minus, you have to take a look again with the given terms. Is the first term perfect square? Is the second term is also perfect square? So examine x squared. As what I have said before, that to know that a variable is perfect square, we have to know that the exponent must be divisible by 2. So since this is 2, so therefore divisible by 2. Divisible means if you are going to divide by 2, the answer is a whole number. So 2 divided by 2, 1. Okay? So 36 is also a perfect square because 6 times 6 is 36. So therefore, this given problem is difference of two squares. So based from the steps, what we're going to do first is we will get the square root of the first and the second term. So what is the square root of x squared? So x divided by 2 divided by 2, so that would be x to the power of 1. So the square root of x squared is x. So if you prefer to use plus in the first factor, it's okay. So what's the square root of 36? So that would be 6. So in the second step, what we're going to do to have the other factor, we just copy these two numbers or two quantities. So that is x minus 6. But if we are using plus here, this operation here must be minus. So if we are using minus first here, we have to write plus on the second so that it will go back again to the concept of multiplying sum and difference of two terms. Because the answer of sum and difference of two terms is a difference of two squares. So again, we just make the reverse to have the factors. Okay? So I hope that is clear. So this is now the factored form of this given expression. So example number 2. Factor the given polynomial x to the power of 4 minus 9y to the power of 6. So again, as what I have said, we have to check whether this given two terms, which is minus difference of two terms, are both perfect squares. So again, the exponent of x here is 4 divisible by 2. The exponent of y is 6, which is also divisible by 2. So the variables x and y are all perfect squares. How about the constant? So the coefficient of x is 1, and 1 is also a perfect square, and 9 is also a perfect square. So therefore, we can say that this given expression is difference of two squares. So again, we just follow the process to factor this polynomial completely. So the square root of x to the power of 4, so x, divide it by 2, so 4 divided by 2, so that would be x squared. So the square root of 9 is 3. Then y, the square root of y to the power of 6 is y to the power of 3. Because 6 divided by 2 is 3. So therefore, this is the first factor. So as what I have said, if you use first here the subtraction operation, in the second factor, it must be plus. But again, you just copy these two quantities. You just alter the operation. So this is now the factored form of that given expression. Next problem. Factor the given polynomial completely. So m to the power of 3 raised m to the power of 3 minus m. So as you can see, in this problem, m to the power of 3 is not perfect square. Why? Because 3 is not divisible by 2. Same goes with m. So how can we factor this? But in our previous lesson, we can consider these two quantities having a common monomial factor. So before we will conclude that this polynomial is prime or not factorable, we have to do everything. So this polynomial can be factored first by common monomial factoring. So the common monomial factor of m cubed and m is, of course, m. Bakit m? As what I have said, the common monomial factor dapat in all terms that variable is present. So in this case, merong m, m with the lowest exponent will be taken as the common monomial factor. So to obtain this remaining factor here, we just divide both terms by the m, the common monomial. So m cubed divided by m, so we just subtract the exponent, so that would be m squared. Then m divided by m, a number divided by itself is equal to 1. Take a look in the perspective that a number, if divided by itself, the answer is 1. So therefore, the factored form of m to the power of 3 minus m is equal to m times m squared minus m. So our factoring does not end here. Why? Because as you can see, this resulting expression in the quantity, as you can see, is also a perfect square. Why? Because m here, the exponent is already divisible by 2. And the constant one here is also a perfect square. And the operation is minus. So this is difference of 2 square already. So we will factor it completely as instructed. So to factor that out, we just copy the common monomial factor that is included in the factors. So again, the square root of m squared is m. The square root of 1 is 1. So you just copy this term to the other quantity, but change the sign. It's gonna be minus. So therefore, this is now the completely factored answer of this expression.